Okay, so here in this question, we are going to find the inverse Z transform of a logarithmic function. Okay, so what happens if the given question is a logarithmic function? We have already learned about finding the inverse Laplace transform of logarithmic function, right? So here also basically the process is basically the same. The concept is basically the same. Only need to understand that for the finding the inverse Z transform of logarithmic function, we are using the property that is Z transform of n x of n is equal to minus z d by dz of x of z. This is the property we are going to use when we are finding the inverse Z transform of logarithmic function. Okay, for any logarithmic function, when you see for Z finding the Z inverse Z transform of any logarithmic function, this is the property we need to use, and basically the steps are also the same. Okay, so let's solve this question. So here the given Z transform is log 1 by 1 minus a Z inverse. Okay, and here so the property is Z of n x of n is equal to minus Z d by dz of x of z. Okay, so here this is nothing but I'm going to substitute the value of the given question in this formula. So this will become minus Z into d by dz of x of z is what? Log of 1 minus a Z inverse. Okay, so now I need to differentiate this, but maybe differentiating directly might be a little difficult, but that's okay. I can just make some small modification to this. I can write this in this format, right? That is minus Z d by dz is log of 1 minus a Z inverse. This is 1 minus a by z. This becomes Z minus a by z. So log of Z minus a by z. Okay, this can also be written as minus Z d by dz log of Z minus a minus log z, right? So now your differentiation will become very easy. So this is nothing but minus z into, so differentiation of log z minus a is 1 by z minus a, minus differentiation of log z is 1 by z, so 1 by z. Okay, now I will multiply these two inside this, so this will become minus z by z minus a plus 1. Okay, or this can also be written as minus z plus z minus a by z minus a, right? So this z cancel and you will get minus a by z minus a. Okay, so basically we have reached this step, that is Z transform of n x of n, you have reached till minus a by z minus a. Okay, so now what we can do, now how I can find the value of x of n, how will I find the inverse of this function? Okay, so to find that, what we will do is, we know that the Z transform of a raised to n u of n, the Z transform of a raised to n u of n is nothing but Z by Z minus a. Okay, so here this numerator Z is missing over here, right? In your given question, this numerator Z is missing. So to put that Z over there, what I'm going to do is, I'm going to change this expression like this, that is Z transform of n x of n is equal to, this will become minus a Z inverse into Z by Z minus a, because Z inverse into Z is 1, right? So this is how I introduce Z into the numerator. So now I know this is nothing but the Z transform of a raised to n u of n. So therefore this will become minus a Z inverse into Z transform of a raised to n u of n. See, so I have reached to this step. Okay, so now next step is, you can see that this is Z inverse into the Z transform, right? We know that according to the time shifting property, Z transform of x of n minus 1 is nothing but Z inverse x of Z. Z inverse x of Z, right? So here This is the time shifting property assuming that the initial conditions are all 0. So this is nothing but Z inverse x of Z. Okay. So therefore the Z transform of n x of n is equal to minus a Z transform of, so it will be shifted by 1 second, so a raised to n minus 1 u of n minus 1. Okay, this is it, a raised to n minus 1 into u of n minus 1, right? This is by after applying the time shifting property, right? So this is how I actually put my Z inverse inside, right? So this is basically, it becomes Z transform of a raised to n minus 1 u of n minus 1. Okay, so in other words, now if I'm taking the inverse of this above function, right, if I'm taking the inverse Z transform of the above equation, then this will become nx of n is equal to minus a into a raised to n minus 1 u of n minus 1. Okay, understood? That is taking the inverse of the above equation. So this becomes like this, right? Or in other words, your x of n will then, it will become minus a by n into a raised to n minus 1 u of n minus 1. Okay, if you want, you can put you can combine this a and this a raised to n minus 1, so it will become a raised to minus a raised to n. So this will become minus a raised to n. Therefore, x of n is equal to minus 1 by n into a raised to n u of n minus 1. So this is your answer. Okay.